All right, guys, here we go. This is 13.3. I think I might have misspoken and said 3.3 last time. I'm not sure. But anyways, this is 13.3. And we got 9 questions. Let's do this thing. Number one, P of A complement if P of A is equal to 0.4. Remember the law of complements, it just says it's 1 minus the probability that you do not have something that's equal to the probability that you do, and vice versa. Probability of A not is 1 minus the probability of A. So 0.6. Number two, same idea. P of C complement is 6/13. What's the probability of C? That's 1 minus 6/13. Let's change that to a fraction. That's 7/13. So you guys know that if you just hit this button in decimals, it goes back and forth. I forgot to tell you guys this, but it goes back and forth from decimal to fraction. Number three, 3 fair coins are tossed. What's the probability at least one is ahead? Okay, to do this question first, let's figure out how many outcomes are possible. There's 3 coin tosses. That means there's 2 to the third or 8 outcomes that are possible in 3 coin tosses. And notice that all of them have at least one head, right? Except for one. So all of them have at least one head except for one. So it's going to be 7/8. Or you can think of it as 1 minus the probability of only 0 heads, which is 1 minus 1/8. And the probability is a fraction, so that'll be 7/8. Yeah. Okay. Number 4. Find the probability of obtaining at least one head in 5 flips of a coin. Hold on a second. All right, guys, I had to take a quick phone call. My car's tires are being changed because I got a flat tire this morning. So got to take that phone call. But oh, here I am back again. Number 4. Find the probability of attaining at least one heads in 5 flips of a coin. Oh, it's basically the same question, just with 5 flips instead, right? So instead of 2 to the third, you got 2 to the fifth, 32 possible outcomes in 5 flips of a coin. All of those outcomes have one head except for one, right? So that would be 31 out of 32. Or you can think of it as 1 minus 1 out of 32. This 1 comes from the one outcome when there are 0 heads. And that's it. Your answer is 31 out of 32. Okay, number 5. What are the odds in favor of drawing a 4 from an ordinary deck? So remember, whenever we say odds, we want to do 3 things. We want to figure out what's the S, what's the F, and what's the T. S stands for successes or wins. F stands for failures or losses, and T stands for total games played or total number of outcomes. So let's look at it again. Odds of favor of a 4, drawing a 4. So how many ways can you draw a 4? There's 4 of those guys. How many cards in the deck first? There's 52 cards. And how many of those guys are not 4s then? 52 minus 4 is 48. Yeah. So what are odds in favor? Remember, odds in favor is always S compared to F. So in this case, that would be 4 compared to 48. Okay, I'm not sure if they accept it as the unsimplified version. I'm going to just check right now. So let's do 4 to 48 and see if they accept that. Okay, if not, we're going to reduce it. Okay, so it actually accepted it as the unreduced version. If you want to, you can reduce this. They'll divide both by 4. You get 1 to 12. What's that saying? It's saying for every one card that's a 4, there's 12 cards that are not 4s. Or originally we had 4 to 48. That's saying for every 4 cards that's a 4, there's 48 cards that are not 4s. Okay, number 6. 3 coins are tossed. What are the odds against getting 3 heads? So again, we want to do the SFT for any of these odds type of questions. 3 coins tossed means there are 2 to the third or 8 outcomes possible. What are the odds against 3 heads? Okay, so how many ways do you get 3 heads? There's only one way to get 3 heads, right? Which means there's 7 ways not to get 3 heads. Odds against means you have failures compared to the successes. So failures is 7, successes is 1. 7 to 1. All right, number 7, probability of drawing a club from a deck of cards is 1/4. What are the odds in favor of drawing a club? I'm sorry, not club. You wouldn't draw a club from a deck of cards. That would be strange. So once again here, we're going to do the S, F, and T. When you're given probability, what does that mean? That means they're giving you the S and the T. So the probability of a club is 1 out of 4. If I have 4 total games and one of them is a win, then I have 3 losses. So now odds in favor. Remember, odds in favor are always S compared to F, wins compared to losses, successes compared to failures. So that's 1 compared to 3. Okay, 2 more questions. All right, racetracks, quote the approximate odds for each race. Something called a tote board. Here's what they might say. Horse number, odds, 18 to 1. When they state these odds, note here, the odds are stated from the horses losing. So 18 is the number of failures. This is S. This is odds against them winning. And what is asking for the probability? All right, so easy. Probability of horse 1 winning. So each of these times, they're giving you the F first. Again, we're going to do the S, F, and T. So F first means that the F is 18. The S is 1. That makes the total 19. What's the probability? It's the S over the T. So 1 out of 19. Yeah. That one was done for you. Okay, for horse 2, it's going to change these things a little bit. S is going to be 2 this time. Failures is 3, right? Remember, failures comes first. That means there were 5 games. So the probability is S over T, which is 2/5. Okay, for horse number 3, failures is 2, success is 1. That means 3 games. Probability is 1/3. For horse number 4, it's 7 failures to every 5 wins. That means there were 12 games. S over T is 5 out of 12. And last horse, 1 win and 1 loss, 2 games. That makes the probability 1/2. Okay, last question. This is a question we started in class, right? I told you in class the entire list, so I'm just gonna do that as fast as I can. Boy, 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 girl. Boy, actually, I'm gonna do like this. Boy. There's 4 children means 16 outcomes. 1, 2, 3, 4, 5, 6, 7, 8. 8 starting with a boy. 2, 3, 4, 5, 6, 7, 8. 8 starting with a girl. From those first 4, the second child could be a boy half the time. And then it could be a second child could be a girl half the time. And then I'm gonna go by 2s this time. So boy, boy, girl, girl, boy, boy, girl, girl, boy, boy, girl, girl, boy, boy, girl, girl. And then last time I'm gonna alternate. So I'm gonna do boy at the end, and a girl, boy, 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 girl. Okay. Okay, so those are all 16 outcomes. We did this part in class together, yeah. What's the probability of 4 girls? Well, there's only one way you get 4 girls out of 16 outcomes possible. Probability of 4 boys is the same. Probability of 1 girl and 3 boys. So if you look at the list, there's going to be 4 ways that you have 1 girl and 3 boys. That means it's going to be 4 out of 16. Similarly, there's 4 ways that you get 1 boy. 2 boys and 2 girls. This is the one that's a little more complicated. Actually, it's come from this choice function, right? If you think about this, each one of these is just an NCR question. From the 4, you're going to choose 2 of them to be boys. So you're going to get 6 out of 16. And last question to add them all up together. This is 4 girls, 0 girls, 1 girl, 2 girls, 3 girls. That's all the possibilities. So if I add them all together, I should get 1. But as a quick check, 1/16 plus 1/16 plus 4/16 plus 4/16 plus 6/16 is 1. So yeah, there you go. Yeah. So I use the choice function to count the number of ways that I get two girls. But if you want to rather just look at the list, you can find them here. Here's two girls. 1, 2, 3, 4, 5, and oh, I miscounted here. Should be 6. Yeah. 1, 2, 3, 4, 5, and 6. There it is. There it is. Yeah, that's how I got this one. Okay, let's check. Make sure you didn't make a mistake somewhere. All right, green checks all the way. There we go. Okay, see you guys next time.